Okay. So I have shared my screen. I think all of you know are able to see it. Yes.
Yes, sir. Yes, sir.
Okay. Okay. So how the process progress is going? Yes. How many of you have started to do some practical on that architectural drawing?
Yes, sir.
कुछ शुरू किया?
अभी सर का
Yes.
सर एक्चुअल में अभी स्टडी कर लिया। अब सर मैं सोच रहा था आज की क्लास हो जाए, फिर एक साथ ही सर वो प्रैक्टिकल मॉडल स्टार्ट कर दूंगा।
नहीं नहीं, कोई बात नहीं, कोई बात नहीं. टेक योर टाइम बिकॉज you will have to work a little bit sincerely on it, and doesn't matter whether you can create the structure or whether there are problems, doesn't matter. Your attempt is very important. So you have to attempt it once, twice, thrice, so that you will start feeling a little bit more confident. Because up till now, what we are doing, we are practicing on some hypothetical structures. तो हमें भी पता
यस
है कि
सर।
ये तो दुनिया में है ही नहीं, ऐसे ही हमने लिया है, तो उसमें जरा मजा नहीं आता एक्चुअल. एंड दैट इज द प्राइमरी रीजन, or we are focusing on that. You will start focusing. So some of you may be working in structure engineers office, so they may have a chance to work on actual structures. But most of the students that we are trying to develop them, they are not having that opening. So that's why we are giving you the practical things. And now, and I think more than making a successful modeling, what we are trying to focus on ourselves is that uh, develop your confidence and get some practical aspects right in the beginning, so that whenever you will start your practice, you will feel a little bit more confident than others. Okay. And
यस
yeah,
सर।
and you may ask me if you have any queries. And with that, today we are not going to open the model, but I find this opportunity so that I will talk to you with number of codal provisions in 1893, and for that we will directly go in 1893, and we'll try. Or you may ask me whether you have understood it, or okay, how many of you have started reading 1893?
पढ़ लिया सर।
Acha. Any? Yes,
यस सर।
Ketan, what about you? Ketan, can you hear me?
यस सर, स्टार्ट कर रहा हूँ सर मैं अभी। आज नहीं किया मैंने।
अभी तक नहीं किया?
नहीं सर।
करना पड़ेगा ना यार. देखो,
यस
आपको
सर,
कभी
आज
भी
रात को ही स्टार्ट करता सर।
नहीं नहीं, सवाल वो नहीं है. मेरा कहने का मतलब ये है कि आपको कभी ना कभी तो इसकी शुरुआत करनी पड़ेगी, अगर आपको इस फील्ड में काम करना है तो. हाँ, अगर इफ यू say that okay sir, I'm just entering in the class just to understand a few basic concept about structure engineering, and I don't have any thought in my mind that I will make a career for it. I'm just entering as a hobby, then it is okay. But if you want to make it a sincere career, you have to go through IS 1893. Okay, now let me ask some questions to Suleka ma'am. Okay, ma'am, you are you working on 1893, or what is the practice there? Because there, I think you are working with ACI code and Eurocode. Yes.
Yes, sir. Yes, sir. We are working in ACI code, but
Okay.
actually my consultant is only doing G+4 buildings. So there is no need to submit here for earthquake
Okay,
analysis.
okay, okay, okay. So you're designing the things with respect to gravity loading analysis and design. That's all. No, why
Yes,
I
because
was asking you, because today
hmm,
I'm going to see few codal provisions. Actually, I will be going through 1893 codal provisions, and for that, I think one thing is there. The principle, whatever may be, see, codal provision may differ from a little bit here or there, but
Yes.
fundamental conceptual understanding is one and the same. Okay,
Yes, sir.
so
Yes.
even if yeah, because see, you may be working in KSI and that, so understanding the things in kilonewton per square meter is a little bit difficult for you, because I don't understand that KSI and KPI unless I convert it in kilonewton per square meter. So the same problem may be with you, but just focus, forget about the magnitude, but try to focus on the conceptual understanding or whatever with respect to that codal provision. I will try to give the explanation and concept behind it, and how it is protecting. Okay, so
Okay, sir.
okay, so let us open that code. So I have already opened it, and you can see, so this is the code. So let me go to this. So this is criteria for earthquake resistant design of structures, part 1, general provisions and buildings. That means there will be part 2, part 3, and you may see. So this part 1 is dealing with general provisions and buildings. So another part may be dealing with bridges or some special structures, stack-like structures, etc. So if you want to go for codal provisions regarding 1893, you will have to see part 1. Clear? Okay. Now these are the things, कहाँ से वो address वगैरह, and it is December 2016. So I am using the code which is just now revised. So in India, we revise the code maybe after 25 years or 30 years. So previously it was something around 78. So after that, 2016 is the revision, and we'll see that. Okay, so you can see that here you will find this is a sixth revision, and you will find the scope. So this is regarding what is the scope of this codal provision, and you can go through that. Now you can see that primarily it deals with earthquake hazard assessment for earthquake resistant designs for buildings, liquid retaining structures, bridges, embankment, retaining walls, industrial and stack-like structures, and concrete, masonry and dams. This standard part, part 1, deals with earthquake resistant design for buildings, earthquake resistant design of the others is in 2 to 5. That means you can say that the 1893 is divided in part 1 to 5. Okay. Then you can go through all such things, and here various references are given. You can see that part 2 is liquid retaining tank, part 3 is bridges and retaining walls, part 4 is industrial structures, and then these are the references which I was working. Okay, then you can see that terminology. So if you see here, it starts with terminology. So whatever the definitions that and these definitions you will see in various books also, but for this reference they have included over here. So what do you mean by closely spaced modes? Particularly this will be looking, and I would like to have few comments about this. Mm, okay. See, you can read it, but conceptually, I will try to show you that closely spaced modes of the structure are those of the natural modes of oscillation of a structure, where natural frequency differ from each other by 10% or less of the lower frequency. And now you can let me show you that. Let us say that you have defined one structure. Let's say this could be a structure something like this, 1, 2, 3, etc., whatever may be. And with respect to free vibration analysis, you have found omega 1, omega 2, then omega 3, etc., then omega 4. So let's say these are the circular frequencies of first 4 modes of vibration that you have analyzed with that pre-vibration analysis. Now, if the difference between, let's say this is the smallest frequency. Now this is the frequency fundamental T1. That means longest time period, or when you are talking about frequency, it will be the smallest frequency. Now this is the smallest frequency. Now the difference between W1, W2, then W1, W3, and W1, W4 is lesser than 10%. Okay, lesser than 10%. Then the modes will be closely spaced. Okay, clear?
Yes, sir.
Now, one may ask me, sir, what happens whether they are closely spaced or they are far away from each other? What is the problem? Why you are trying to identify whether they are closely spaced or placed with uh, uh, um, I will say that they are away from each other. What will be the problem? See, let's say you are having a frequency something as 1 radian per second square, or let's say in hertz, let's say it is 1 hertz, and another frequency is, let's say, 1.05 hertz. Okay, so this is your omega 1, this is your omega 2, and let's say another frequency is 1.10 hertz. Now you know that earthquake is changing its frequency, and every frequency will vibrate. Now, if it is passing from this to this, it's very easy. From this to this, it is very easy, and that's why when one frequency is converted in another frequency, so earthquake is changing its frequency. The interference of these frequencies will have uh, I will say some effect on your structure. But if one frequency is 1 hertz, another frequency is say 5 hertz, and third frequency is, let's say, 10 hertz. Now the effect of this frequency, vibration of this frequency and effect of vibration of this frequency, they are away from each other, so they will not interfere, so the effect will not get interfere. Understand? Hello.
Yes, sir.
Now you are using SRSS. So finally SRSS, sum of square root of sum of squares, SRSS method. Now if these frequencies are well separated from each other, then SRSS will give you a predictable behavior of the structure, or you can predict the structure properly. But if the frequencies are very close to each other, let's say 1.05, 1.07, or 1.1 something, that means code has given you that 10%. 10% or less of the lower frequency, then this SRSS method cannot cannot uh, um, um, measure the effect of say mixing of one frequency, or say what we call as the interference of one frequency, effect of one frequency on another frequency. So this method cannot properly detect that effect, and that's why you are using CQC. Okay. So calculation of SRSS and calculation of CQC is I will say that it's a advanced process. जिनको बहुत ही डीपली काम करना है वो कैलकुलेशन में भी जा सकते हैं, बट आपके जैसे और मेरे जैसे लोग बोलेंगे भैया हमको इतना तो पता चला कि क्लोजली स्पेस अगर फ्रीक्वेंसीज है, so they will interfere, the effect of them will get interfere with each other, and because of that, that effect cannot be measured by SRSS, and that is that defect is or the effect is overcome by use of CQC. Okay, so that is, and now you can read this closely spaced mode definition. So whether and now in queries or in your interviews, one may ask you why you are calculating closely spaced modes, or why you want to check whether the calculated frequencies are well separated or they are mixed with each other. uh, what is the necessity? And then you people will not understand अगर ये concept आपको पता नहीं है तो, right? Okay.
Yes, sir.
Now this is about critical damping. Now, what is damping? Yes, anybody can let me know what is damping?
So the effect which decrease the oscillation over a period of time is called
Yes.
damping
Yeah. So, and
through
why
physical
that?
through physical friction
Yes.
of the medium.
No, actually, see, damping is a very complicated process. Lot of things are coming in picture, so that the damping effect is. Now we are not interested in finding all the parameters why the damping is coming in picture. We are just saying that what we are interested. What is the effect of damping? So, effect of damping is a reduction in amplitude. Clear? As you go from start to end, you will see that amplitude, or this part is called amplitude. Okay, so this part is called amplitude. So as you go from first cycle to second cycle, third cycle, fourth cycle, you will see that the damping, the amplitude is getting reduced, and that effect is called damping. Now, what is critical damping? Now you can see that the damping beyond which the free vibration motion will not be oscillatory. अब ये इनिशियली समझना जरा मुश्किल होता है लोगों के लिए, पता नहीं आपको पता है व्हाट इज क्रिटिकल डैम्पिंग? यस, see what will happen. One structure will have something like this. Okay, so if the structure is critically damped, it will have, so it will not go in oscillation. Okay, then another structure which is over damped, you will see that it will also will not interfere or will not go in this, but it will go like this. So there is no oscillatory effect. So this is critically damped and this is over damped, and there, and most of the structures are under damped, and because of that they go vibration something like this. Okay, and now you can see the damping beyond which the free vibration motion will not be will not be oscillatory. So this part is called a critical damping, and that critical damping, you will see that psi. Psi is a percentage of damping, and critical damping we call it as CC, and actual damping we call it as C, and psi is nothing but it is equal to actual damping divided by critical damping. So this is critical damping, this is actual damping, and psi is the ratio. And most of the time you will see that in concrete structures we are considering psi equal to 0.05, or we say 5%. Clear? Yes.
Yes, sir.
Yes, sir.
And that's why you will see that whenever you are going for your ETAP model, it is saying that what is percent of damping. That percent of damping is nothing but xi, a value of xi, which is expressed as ratio of actual damping over critical damping, and then critical damping is defined like this. Yes, I think conceptually you are getting into the scene or not.
Yes, sir.
या बोर हो रहा है
Sir.
बोर हो रहा है
Yes, sir.
No, sir. बोर नहीं हो रहे.
अच्छा ओके नहीं कोई प्रॉब्लम नहीं थोड़ा बोर तो मैं करूंगा क्योंकि वो मेरा हक है okay the effect of now you can see what is defined as a damping in our code, that effect of internal friction, inelasticity of material, slipping, sliding, and whatever may be, that all these effect which is reducing the amplitude of oscillation is expressed as fraction of critical damping. And exactly that is what I have given you as C upon CC. C is actual damping, and CC is critical damping, and uh, damping is expressed in ratio xi. So this xi is nothing but damping. Then I think I have explained this design acceleration spectrum, which is the average smoothen graph of maximum acceleration as a function of natural frequency and natural period of oscillation for a specified damping ratio for expected earthquake excitation as the base of single degree of freedom. Yeah, this is very important, and I would like to spend a little bit time on this. Yes, have you understood this? Hello.
Yes, sir.
Design acceleration spectrum, but why it is defined and how it is used. See, the my question is that, see, what when you are going to study the effect of earthquake on various building, see, you will see that earthquake is very notorious, and it is having every time it is having different parameters. Uh, let's say that you are staying in one area, and that area is subjected to earthquake. Now it that area may get subjected to earthquake from any distance. बराबर ना? As the focus is near to you, you will be subjected to higher vibrations, and you don't know where the focus is, because if you see, if you try to visualize the uh, earth. What is happening? If you try to visualize the earth, you will see something like this. And inside the earth, there may be anywhere, there may be a focus, anywhere. And you may be anywhere on the periphery of the earth. So you do not know anything. So how we are going to analyze the things where we do not have any information, and that's why some standardization has been prepared. And what they have done, because every earthquake will be different, so what they have done, so let's say this is the surface of earth, and yeah, there is a building something like this, then there will be another building something like this, then there will be something building like this. Now every building, you can see that every building is having different parameters. Yes, क्या सभी बिल्डिंग सेम है?
No,
No, sir.
Requirement will be different. This may be a residential building, this may be a hotel, this may be some part as parking, then some part as commercial, some part as something else. So you may have, let's say, you may have here some sort of huge structure, maybe a stadium, maybe something else, theater, etc. So every structure is different, and that's why what say they say that let us find the effect on a single degree of freedom. So they are considering this as a uh, theoretical structure, this as another building having single degree. Now we are not talking about multi degree. So we are having single degree structures. So single. So all these are single degree freedom system. We are representing the building as a single degree freedom. So this will have one frequency. This will have another frequency. This will have uh, this another frequency, and this I am talking about character of the building. And now there will be earthquake. Now this earthquake itself will have bunch of frequencies. Okay, this earthquake will also have bunch of frequencies, and few frequencies may be near this, maybe near this, maybe near this, and maybe near this. And the effect, or I will say the building will get distorted or deformed to its higher level only when the frequency, let's say f1, f2, f2, f3, etc. So there are n number of frequencies that this earthquake is carrying along with him, and earthquake is changing its frequency at every fraction of second. तो ऐसा नहीं है कि earthquake is having only one frequency. It is having bunch of frequencies along with him, and every time or fraction of second he is changing his frequency. The moment, let's say, the moment W1 is very near to one of the frequencies, this building will vibrate. Otherwise, this building will not vibrate. Clear? समझ में आ रहा है आपके?
Yes, sir.
Or you can imagine it like that you are having some radio set with you, and there are n number of stations where they are having their program on some definite frequency. Okay, now your radio set will you will make it enable to understand the song only when you will match the frequency of your radio set along with that frequency, right? The same way, this is the frequency of this building, this is the frequency of this building. Now this building will get vibrated or it will deflect maximum only when it will match one of the frequency. Same with this. And we do not know when W3 is matching with the basket of this earthquake, when W4 is have a matching with this, etc. And finally we get these mode shape, maybe something like this, or maybe something like this, right? Yes, are you getting it?
Yes, sir. Yes, sir.
Now what that spectrum concept says that will have a smooth spectra for all such frequencies, maximum frequencies, and that smooth spectra is defined something like this. So where this is t, which is the time period, and this is the effect, which is in terms of SA by Z. And then with applying this, now this is for n number of earthquakes. So all that data, so finally preparation of this response spectra is a very cumbersome process, and it takes a lot of data to be analyzed, and finally we are making a smooth function. That means this does not does not represent any specific earthquake. It's a smoothen earthquake response spectra that has been developed by analysts or mathematicians, or you can say geophysics scientists, and we are using this, right? Because many times when I ask the people that this response spectra is how you can use this to analyze your building for some probable earthquake, because you are designing, that means you are designing a building for some future earthquake to safeguard the building against some future earthquake which have not yet defined. So you will get the data only when that activity will be exercised. Then how come uh, you understand that you will say on what basis you are saying that your building will resist? Because this response spectra is having n number of earthquakes. Let's say this is one earthquake, and this is the data of available earthquakes. Then there will be another earthquake, so maybe anything something like this, right? Then there will be third earthquake. So कितने आज तक जितने earthquake हो गए हैं, वो सबका डाटा का वैल्यूज लेके ये रिस्पॉन्स स्पेक्ट्रा डिफाइन किया गया है। क्लियर हो रहा है थोड़ा थोड़ा?
Yes, sir.
And that's why we can see that at least, though I don't have data of the future earthquake, जो भविष्य में घटने वाली चीज है उसका तो डाटा पहले नहीं मिलेगा ना, फिर भी I can predict that because I have gone through thousands of previous earthquake data which has been analyzed, and some information is drawn with that, and that is why this design acceleration spectrum means number of such earthquakes. And why it is called design? Because it is not truly representing any actual data, it is representing a average smoothen data. ये कंसेप्ट आपको क्लियर हो रहा है? एवरेज स्मूदन डाटा. So it is
Yes,
not,
sir.
yeah, it is not actually representing any data. Say you may say that, let's say with actual calculation you are getting your structure something like. So this output that has been the outcome of various earthquake, it has been smoothened. It has been smoothened like this, and that's why you can see this blue line is this design. That's why it is called design spectrum, and it is of acceleration. That's why it is called design acceleration spectrum. Clear?
Yes, sir.
Okay. So like that, you can go through this, then acceleration, horizontal force, ductility, you can go through this. You can go through this epicenter, then flow response. This is not used by us most of the time, so you can neglect it or ignore. Then importance factor, you can see that. And now you may have some more information about intensity of earthquake. So what is the difference between intensity of earthquake and magnitude of earthquake? So you can go through the books, so you will understand. Try to read the book, and if you do not understand, then in next time I will try to explain you what is the difference between intensity of earthquake and magnitude of earthquake. Right? Now, how intensity is measured? So intensity is measured with respect to the damage that has been considered So that damage is defined in 1 to 12 categories. So it's not because of the earthquake. It's because of whatever situations on ground you are having. Let's say if the earthquake uh, any let's say any desert has been shocked by the earthquake, what will be the damage? There will be no damage because there are no activities coming, so human activities in the desert, right? are you are you getting it?
Yes, sir.
So barren piece of land, there will be no damage as far as human beings are concerned. But if the locality of that is say a city or very densely populated city or slum area or the area where people have not taken care to create the structures which are earthquake resistant, then if under such so on such areas, if that those areas are subjected to earthquake, they will face maximum damage, right? So damage is not because of earth, damage is because of the situation or geophysical conditions at that ground, and whatever developments that we have carried, the standard of those developments. So based on that, they have defined 1 to 12 different categories, and that is called intensity of earthquake. And what is magnitude? Magnitude is a measure of energy released. Okay, when the earthquake is erupted at focus, the energy is released. So the measurement of that release of energy, the magnitude of the energy release is defined as a magnitude of earthquake, and intensity is uh, I will say that intensity corresponds to the extent of damage. And there are again there are n number of parameters how to calculate. So there are MSK scale for seismic intensity. Then there are five six different intensity modified MSK scales. Then this MSK means uh, it has been now this MSK scale has been accepted worldwide, and that's why India also they are using MSK scale. But there are other different scales also. Then don't look into this liquefaction because it is a rare activity. Then if you are interested in lithological features, then you may go through this lithological features. So that is a part of geology. And here you can see modal mass. So I have already explained this concept, so I'm not going to repeat it. So modal mass and modal participation factor, etc. All these, then modes of oscillation, then mode shift coefficient. I have already explained those things. So you can just go through this. Then what do you mean by natural mode period or natural period of mode K? Then you know also fundamental lateral translation, natural period, then modes of oscillation. So these are the definitions. Then peak ground acceleration. Uh, Now this is a concept where number of people get confused. So peak ground acceleration, it is expressed as a zero period earthquake or zero period earthquake intensity. So how I can define? Okay, we'll work on it later. Peak ground acceleration. But even if you do not understand much about this right now, I'm not saying always. Right now, try to ignore this till your understanding level goes on increasing. See, one thing is there, uh, and I have observed people do not read this codal provision because the moment they start reading this, they find it very difficult and number of terms they do not understand, वो फिर they feel that यार नहीं ये मेरे बस की बात नहीं, and they quit. Don't do that. मैंने जब पहली बार शुरू किया तो आई वॉज ऑल्सो नॉट अंडरस्टैंडिंग, देन अभी जो मैं एक्सप्लेन कर रहा हूँ ना वैसे ही मैंने सीखने की कोशिश की। मैं बोला नहीं, आई विल ट्राई टू अंडरस्टैंड वन बाय वन, आई एम नॉट इंटरेस्टेड इन एंटायर कोडल प्रोविजन, I will go one by one. Okay, what is mean by normal mode of oscillation? Then I find that I don't know about oscillation. Then I went to oscillation. So ऐसे ऐसे धीरे धीरे you will go back and then again you will confront, right? Hello.
Yes, sir.
See, if you do not follow this and if you expect that you will if you understand only then you will read it, then I will say that you will never attempt to read it, क्योंकि यही तो मैक्सिमम 99 आउट ऑफ 100 लोगों का प्रॉब्लम है, बिकॉज दे हैव सम वेग आइडिया इन देयर माइंड। उनको ऐसा लगता है कि नहीं, अब मैं इतनी मेहनत कर रहा हूँ, बुक पढ़ रहा हूँ तो मुझे समझना चाहिए, और नहीं समझता है तो आई एम नॉट गोइंग टू अटेम्प्ट इट। तो ये नहीं समझेगा, ये पहली बार नहीं समझेगा, दूसरी बार नहीं समझेगा, तीसरी बार नहीं समझेगा, चौथी बार भी नहीं समझेगा, फिर भी आपको धैर्य रख के you have to read it, and then there will be one stage you will find that yeah, now I understand each and everything, and then go ahead with that. तो आपको क्या लगता है, ऐसा ही होता है ना आप लोगों के साथ? यस, हेलो।
So बार बार जितनी बार पढ़ते हैं सर उतनी बार ज्यादा क्लियर होता जाता है सर।
हाँ राइट, और पहली बार कुछ नहीं समझता है।
यस सर, पहली बार सर आपने वो मोड ऑफ ऑसिलेशन मैंने आपको पूछा भी था, वो इसमें से पढ़ के समझ ही नहीं आया था, फिर आपने बताया तब जाके वो दोबारा पढ़ा तब क्लियर होने लगा।
यही है प्रोसेस, एक्चुअली दिस इज द प्रोसेस, and we do not know that this is the process, and that's why either we get angry with our mentors, or we get angry with ourselves and we leave that activity. एक्चुअली ऐसा नहीं है, आपके मेंटर को आप पूछो, उसको भी इसी फेज से जाना पड़ा। अभी मान लो कि मुझे तो किसी ने सिखाया नहीं, क्योंकि अनफॉर्चुनेटली आई स्टार्टेड रीडिंग ऑल दीज थिंग्स व्हेन आई लेफ्ट द कॉलेज, और कॉलेज लेफ्ट करने के बाद भी नौकरी करने के बाद 5 साल के बाद आई स्टार्टेड, मुझे भी समझना चाहिए। सो आई वाज नॉट गोइंग इन एनी कॉलेज, सो आई वाज नॉट हैविंग मेंटर विथ मी, और जो थे उनकी फीस मैं अफोर्ड नहीं कर पाता था, so I started on my own. मैं आपको बताता हूँ, लिटरली 10 बार 20 बार मैंने पढ़ने के बाद 2-4 दिन बंद किया, फिर वापस चालू किया, फिर बंद किया, फिर वापस चालू किया, और उसके बाद समझना शुरू हुआ। सो हो सकता है समटाइम्स यू माइट फील एग्जॉस्टेड, तो 3-4 दिन छुट्टी ले लो, कोई प्रॉब्लम नहीं, बट दोबारा अटेम्प्ट करो। ओके, देन okay, this response reduction factor is you can see what is this. It depends on perceived seismic damage performance of the structure, characterized by ductile and brittle deformation, redundancy in the structure, or strength inherent in the design process. All these things are very important. So there is an inherent design overstrength. There is a inherent overstrength that is in your structure. Then there is a redundancy in the structure, and there is a ductile or brittle deformation, and there is perceived seismic damage performance. पता है आप लोगों को ये थोड़ा, या जानना चाहेंगे मुझसे? हेलो,
थोड़ा सर आप बता दीजिए एक बार।
See what is the meaning of this first statement. So perceived seismic damage performance of the structure, इस पर ही काम करें। इससे क्या पता चलता है, बाकी छोड़ो, बाकी बाद में देखेंगे। वो इलास्टिक क्या है, इंड्यूस शियर इंड्यूस इन स्ट्रक्चर, वो क्या है वो बाद में देखेंगे। इसका मीनिंग क्या है, परसीव्ड सिस्मिक डैमेज परफॉर्मेंस ऑफ द स्ट्रक्चर। यस, and where it is related। मैंने आपको बताया था कि यू कैन नॉट डिजाइन अर्थक्वेक प्रूफ स्ट्रक्चर। सो उसकी वजह से क्या होता है, वी हैव अ प्रोबेबिलिटिक अप्रोच, we have probabilistic approach that, and the approach is that if the structure is subjected to minor earthquake, छोटा मोटा होता है ना, ये ढाई ढाई 3 रिश्टर स्केल वाला। यस, हेलो,
यस सर।
आप लोग है कि नहीं मेरे साथ?
यस सर।
है सर, यही है।
तो हाँ ना बोलो यार, मुझे वैसे पता नहीं चलता है। Okay, see there are see a structure, you don't know what intensity of the earthquake will your structure will be subjected to, what intensity of earthquake। Okay, तो आपने क्या किया कि मान लो आपका स्ट्रक्चर माइनर अर्थक्वेक को सब्जेक्ट हो जाता है, which is something around 2 to 3 Richter scale। Okay, हेलो।
यस सर।
सो ये इतना जो इंटेंसिटी है ना, दिस इज कॉल्ड अ माइनर मैग्नीट्यूड ऑफ द अर्थक्वेक। सो दिस इज कॉल्ड अ माइनर अर्थक्वेक। थोड़ा सा हो जाता है, एक 2-3 सेकंड, या हो सकता है 5 to 10 seconds, and then the things are okay, normal। So when the structure is subjected to such minor earthquake, and the probability is almost more than 70% that your structure will be subjected to this, maybe within 1 month or 2 months, or once in a 3 month, once in or twice or thrice in year, your structure is subjected to this minor earthquake, which we do not notice। बट एक्चुअली अगर वहां पर सिस्मोग्राफ आप अप्लाई करेंगे ना बिल्डिंग में, तो एवरी टाइम यू विल within 2 or 3 months you will find that the seismograph, you are getting seismograph of that earthquake। So the earthquake is there, but you don't get notice, and under that type of structures, your structure behaves in elastic manner। Now what is that elastic? That means no damage, I will say no damage। आपको पता भी नहीं चलता कि अर्थक्वेक आके गया, नो डैमेज। आपको कैसे पता चलेगा? डैमेज होने के बाद ही चलेगा ना। यस और नो?
यस सर।
So if you are not having any instrument that can measure the earthquake activity, then you will notice only when some damage is your building or structures is subjected to some sort of damage। That means हो सकता है बालकनी में कुछ गड़बड़ हो गई, वो जो कुछ रखा था वो गिर गया, या सीलिंग को थोड़ा बहुत क्रैक हुआ, या खिड़की जो आपके विंडोज है वो थर होने वाइब्रेट हो गए, राइट। So in that type of structures, your building will be elastic। That means there will be no damage। So this is how you are creating the philosophy to resist the structure earthquake activity by the structure। Let's say moderate। अब हो सकता है कि your building may get subjected to moderate earthquake। Moderate means maybe something around 3.5 to 5.5। Okay, now for this earthquake, if you want to design your building to behave in elastic manner, what you will need? You will need higher size higher reinforcement, higher money, and that means finally you will have to invest a lot of money. Now, what is the probability that your building might get subjected to this? Maybe once in 25 years. Maybe. I'm just saying, don't get it like that only. Minor earthquake. So there is very less probability. इसका probability कितना है? Maybe once in a month, maybe once in 2 months, or once in 3 months, or 3 to 4 times a year, right? तो आपको डैमेज एक्सेप्ट नहीं है, तो आपने डैमेज कंट्रोल किया. सो योर बिल्डिंग इज वर्किंग इन इलास्टिक फेज. नाउ इन दिस केस यू से दैट ओके, कोई बात नहीं यार, 25 साल में एक बार अगर मुझे खिड़की बदलनी पड़ी, डोर्स एंड विंडोज तो बदलने पड़े, या उसके ग्लासेस बदलने पड़े, या बिल्डिंग पीवी मैसनरी जो है वो क्रैक हो गई और पेंट वगैरह निकल गया, वो बदलना पड़ा, तो कर लूंगा ना. सो यू एक्सेप्ट द डैमेज एंड यू से दैट बिल्डिंग इज इन सेमी इलास्टिक. Semi elastic. Yes, understand that. So you're not saying, see, it is getting damaged, but the damage that you define that okay, BB masonry thoda crack ho gaya, okay, that is accepted. So that is called a perceived damage. See, you are not saying that the building will collapse and people will lose their life, because in 25 years you will not, nobody will allow that okay, कोई बात नहीं, 25 साल में एक बार वो बिल्डिंग के लोग अगर उनकी जान जाती है, जाने दो, 25 साल में एक बार जा रही है ना, ऐसे थोड़ी बार बार जा रही, ऐसा होगा? हेलो, यस, चलेगा? यस और नो?
No, sir.
That's why we say that okay, there is a damage, but that damage we will define. You don't say that any damage will. So we'll take care. We'll design the building in such a manner that there will be no failure in structural elements. Non-structural elements may get damaged, which we will repair. And under severe झटका, राइट, ये जोर का झटका जोर से लगे, तो अंडर दिस सीवियर maybe something more than 7.5 to 8.5. This is severe, and the probability of this is 1 in 500 years, maybe, or maybe 1 in 1000 years, or 1 in 250 years. In that case, we see that the structural members also get damaged. Structural members also get damaged, but building will not collapse. So collapse is prevented. CP, collapse is prevented, so that people in the building will not lose their lives, but they will be survived and will get enough time. And that is all defined in perceived seismic damage performance of the structure. Clear?
Clear, sir.
Now this perceived seismic damage performance of the structure is characterized by ductile. That is what I was saying. I am not going to allow this brittle deformation, but I will allow the structure to behave in ductile manner, and then there will be redundancy in structure. You know what is meant by redundant structures. So because of that also, the structure is having a factor of safety, and you are not designing the structure only for exact strength or required. You are going for over strength. So you are designing for some higher value. So that is also called as over strength inherent in design process. अब मुझे लगता है कि वो आपको पढ़ने में मजा आएगा. Yes.
Yes, sir.
So this is how you have to read this. Then I have given enough information about SA by G. Then you can see all these rest of the structures. You know all this. You can. I think we have covered all this. Okay. So what is main special terminology for building is base. What do you mean by base? Then base dimension, center of mass, then center of resistance, then eccentricity. We have talked about it. Then design base shear, then diaphragm, height of floor, height of building. Then you can go through this horizontal bracing system, joints, then lateral force resistance system, moment resisting frame, then the various part. You can read it and you will understand it. Then if you do not understand this 4.16 initially, then you may ignore for few days and later on you will start understanding this. Then you can see principal plan access, then this P delta effect. If you do not understand right now P delta effect, forget about it. You will understand it later on. Then RC structural wall, we have talked about it. Then story, then what do you mean by soft story, weak story, and drift. I think we have talked about this and will also, okay, let me show it in with the concept. Let's say this is your floor, and earthquake is subjected. The forces, lateral forces due to earthquake, are acting in this direction. Because of that, there will be let's say you're having like this. So this is your delta 1 and this is your delta 2. So that is lateral deflection delta 2. Okay, and this is your floor height, let's say H. Then delta 2 minus delta 1 is called a relative displacement. Okay, so what do you mean by relative displacement? Is nothing but delta 2 minus delta 1. Okay, then divided by height of the structure, height of the floor to floor height, let's say HI, we'll say HI, height of the floor from this floor to this, so you can call it HI. This is called a story drift. Clear? अब इससे आसान
Yes,
तो
sir.
मैं करके नहीं बता सकता. Yes, clear or not?
Yes,
Clear,
sir.
sir, clear.
So now, if you get the model, you will analyze the model and you will find the story drift, and then you will understand the meaning of that. Why I am showing you this is the reason for that is only this. You can say that in ETAB, you are getting a story drift value something like this. Maybe this. ETAB will always say that a story drift is like this. So it doesn't have any unit. Because delta 1 is in length unit and H is also in length unit. So that's why it's a ratio. And there is always a confusion. People do not understand this value. Oh, बोलते हैं बहुत कम आ गया. Right?
Yes, sir.
Yes, sir.
But try to understand that it is delta 1 minus delta 2. This is the, if you see this as in mm, and then you will be confused. आपको ऐसा लगेगा कि बहुत कम आया, ऐसा नहीं है. It's not with unit, because it is delta 2 minus delta 1 divided by h, which is a ratio, and based on that you can find the displacement. So relative displacement divided by floor height, that is a story drift. क्यों मैं आपको बताता हूँ यार, मैं जब इंटरव्यूज लेता हूँ ना तो लोग मुझे इसका नहीं बोलते सर वो कोड में है वैसे करते हैं. तो कोड में तो सब बराबर है, तुम्हें नहीं कुछ मालूम, बिकॉज यू कैन नॉट एक्सप्लेन. एंड अगर आपको पता है तो आप एक्सप्लेन करेंगे, और अगर पता नहीं है तो यू कैन नॉट एक्सप्लेन. क्लियर?
क्लियर सर.
अब शायद आप अगर कहीं इंटरव्यू के लिए गए तो कम से कम आपके साथ ये नहीं होगा, आप बोलेंगे नहीं सर मैं क्लियर बताता हूँ उसका मीनिंग क्या है, बिकॉज आई नो इट. ओके, नाउ जस्ट गो थ्रू द जनरल प्रिंसिपल्स. मैं ये पूरा पढ़ नहीं पाऊंगा क्योंकि उतना टाइम नहीं रहता है हमारे पास, बट यू कैन गो थ्रू द जनरल प्रिंसिपल्स. दीज प्रिंसिपल्स, सी, these are the base for creating our earthquake analysis assumptions, and the base behind that, whatever you are developing the theory, every theory must have some base, no? And that base is over here. See, you can see that ground motion, it is a character, intensity, duration, and frequency content. Now these people do not understand this frequency content. It is nothing but number of frequencies. As I said, every earthquake is having a basket of frequency with him. होता है ना, एक बास्केट होता है, वो बास्केट में तरह तरह के फूल होते हैं. वैसे ये अर्थक्वेक के पास एक बास्केट होता है, उसमें अलग अलग फ्रीक्वेंसी होती है, और वो बोलता है चलो अभी ये ले लो, फिर ये ले लो, फिर ये ले लो, फिर ये ले लो, ऐसे एवरी फ्रैक्शन ऑफ सेकंड it is changing. Then it is also having a different duration and intensity. So the character of the ground motion is defined by three basic parameters: intensity, duration, and frequency content. And that is of seismic ground vibrations expected at any soil site depending on magnitude of earthquake, focal depth. Now ये तीन character कहाँ से आते हैं? Because of magnitude of earthquake, then because of focal depth. Focal depth means depth, vertical height of the focus, or depth of the focus from the epicenter. Okay, so then epicentral distance, then character of the path. Now again, what is this character of path? Yes, जब पता नहीं चलता है ना तो फिगर निकाल के कोशिश करनी. लेट्स से दिस इज माय सरफेस ऑफ द अर्थ. ओके, and on surface here I have built one building. Let's say the building is standing, nice building, but somewhere here there is a focus where earthquake has erupted. Now what is it will go like this. So this is the shortest path to the building from this, maybe in terms of kilometers, maybe say 500 kilometers. अभी ये 500 किलोमीटर में क्या है? यस, यहाँ पे क्या है? हवा है, पानी है, क्या है? मीडियम है.
यस सर.
और कौन सा मीडियम है?
अर्थ है सर, अर्थ क्रस्ट.
तो अर्थ इज नॉट अ सिंगल मटेरियल. ऐसा नहीं है ना कि ऊपर से लेके नीचे तक पूरा मटी है. एवरी डेप्थ यू विल हैव सम डिफरेंट लेयर्स. So you will have some different layers. Okay, तो ये जैसे बदलता है ना, ये जैसे बदलता है, and that is called that is what is called as what is the path? Wave. See, wave is going like this, and this wave is obstruct, the medium will obstruct the wave. जैसे आपको पता है पानी से वेव जल्दी निकल जाएगी, रॉक से उसको समय लगेगा, या बीच में अगर कोई गैप है तो immediately it will flow. Then so that means what material? So that is exactly, you can see uh, the path through which seismic waves are traveling, soil strata on which the structure is founded, and random earthquake ground motion. So all these, and so I'm just mentioning the things. सारी चीजें तो मैं एक्सप्लेन नहीं कर पाऊंगा, बट देखते हैं क्या क्या एक्सप्लेन कर सकता हूँ. So you can go through this, and if you do not understand, try. You can ask me that specifically. सर हमने वो पढ़ लिया, 2 बार पढ़ लिया, 3 बार पढ़ लिया, एक बार लिख भी लिया, फिर भी नहीं समझ में आया. Then we'll have a separate discussion on that. Yes, clear?
Yes, sir.
Okay. Then you can go with this. So this is about then all these soil structure. Okay, this soil structure interaction, don't go into that because we are not using soil. See, this, what is this soil structure interaction means? See, the structure is resting on earth. Okay, or I will say earth is supporting the structure, and the earth is subjected to this earthquake. Now, because of that, the nature of soil, the different types of earthquake characterization will come in picture, and because of that, the upper superstructure will uh, it will vibrate, and because of that, again that effect will be also transferred on the soil, and then again the soil will transfer the effect on superstructure. That is called soil structure interaction. But that's a complicated concept, and you may keep this option initially. Later on, you will understand that. So soil interaction, and people are see, the people who are interested in earthquake engineering, there are separate n number of theses people have carried on only on soil structure interaction concept, and many of them have got the thesis sanctioned and they got the PhD. So it's a vast topic, but I will say that if you are interested, you can go into it, or if you're not that much, you can leave it. That will not hamper your normal analysis process. Okay, then equipment, etc. You can go. This, then change of occupancy not required, and you can go through these assumptions also, because these assumptions are also important. You can just go through that, and you will find lot of important understanding. Okay, then load combination. We have talked about this, and these are the load combinations. You can see that ELX plus 0.3 ELY and 0.3 ELX plus ELY. ये कहाँ से आया? That you can understand over here. So these are those basic combinations, or with the help of this only, we have developed all those whatever 50 or 64 combinations. You can check it and you can find it over here. Yes, and in case of many people ask why, sir, we are not considering vertical earthquake effect. The clause is this 6.3.3, which is saying that effect due to vertical earthquake shaking shall be considered when any of the following conditions apply. That means whether your structure is located in zone 4 and 5. So in zone 4 and 5, you are supposed to analyze the structure for vertical earthquake effect also. That means EQX, EQY, and EQZ also. Okay, so that is one condition. Another condition that when the structure has vertical or plan irregularities, means very complex structure. You may say complex architectural configuration. In that case, also you will have to carry out analysis, including vertical earthquake. Then structures which are resting on soft soil. So the if the structure is resting on type, you have seen that type 1, type 2, and type 3. So if your structure is resting on type 3 type of soil, then you will have to carry out vertical earthquake. You have to find out vertical earthquake effect, and you have to take care of that in design. Then bridges. Then structures are having long span. Even if in residential structures, if the span of your beams or slabs is maybe something more than 10 meters, then you will have to go for and check this vertical effect. And horizontal overhangs. See, normally I ask the architects to get rid of this unnecessary overhanging balconies. Don't go for overhanging balconies, and don't go for unnecessary overhang in subsystem. If it is giving you some additional benefits, then you can go, and then you will have to analyze your structure for vertical earthquake also. Clear?
Yes, sir.
Yeah. Then this about combination for three directional earthquake ground. So that is what we provide this information in directional combination. अब आपको शायद पता you might be recalling that whenever we were feeding the information to our software, that is ADAB, about the earthquake in dynamic analysis, we were saying that combination, when the model combination is to be considered, then go with CQC, and when directional combination is considered, you can go to SRSS. So that is this directional earthquake ground shaking, right? It is having in different, you are having effect in X direction, Y direction, and Z direction. And if you want to combine all that, then you will have to consider ELX plus 3% of ELY, I mean 0.3, 30% of ELY plus 0.30% of ELZ if you are going for 3D. Otherwise, 30% of orthogonal effect. Clear? So एक बार plus, एक बार minus. So this will see if I'm going for only this much, because I am not going for this EQZ, then I will have plus plus, minus minus, plus minus, minus plus. So four combinations over here, four combinations over here, and four combinations over here, and then you will see that your combinations are going to increase. But right now we don't have any problem, because all those combinations results and worst combination, finding the worst combination is the duty of software. So you can go ahead. Otherwise, manually it becomes very, very tedious. I'm not saying difficult, but tedious. Okay. So with this, you can go ahead and you can check. And now all that, whatever we have seen in our PPT, you can correlate it with this design acceleration spectrum value, this AH, Z by 2, SA by Z. We used to say earlier, we used to say I by R. Now we are saying divide by R by I. I have not understood why it has been. Finally, वही तो बात कर रहा है ना. डिनोमिनेटर पे r by I लिखो या न्यूमरेटर पे I by R लिखो. It is one and same, but I have not understood this, why it has been changed. And earlier it was not. So in 1893 2000, it was written whatever we have given you, I by R. But now they have changed it and they say that Z by 2 into SA by Z divided by R by I. The only thing, probable thing that I want to say, but I am not confident because इसको मुझे कोई confirm नहीं करता है. I have asked a number of experts in this field why this has been changed. But according to me, the code wants to have a parameter R by I, because in one case you are increasing importance factor, that is you are increasing it from 1 to 1.5, maybe 1.2, 1.3, 1.4, 1.5, and in another way you are reducing the response. So finally ऐसा ना हो कि R by I goes beyond that some 5 value. Are you getting it?
Yes.
या नहीं? Let me do it. See, मेरा हमेशा ये रहता है कि I used to say let us put it in figure and find out what will happen. Let's say I'm not changing anything over here, so I'm not worried about this. Let's say my R is equal to 5 and I is equal to say 1. So finally, I'm getting 20% because whatever may be this value, I'm getting divided by 5. Yes. So at least I know that at least I am designing the structure for that 20%. तो अगर 100 किलो न्यूटन का that severe earthquake का बेशियर होगा, तो at least I am going for elastic manner criteria. I am going for that 20, and beyond that my damage corresponds what we call as perceived seismic damage, that will come in picture. Beyond that it will not come in picture if it is less than base shear is less than 20 kilonewton, provided that worst base shear is 100, or you can say 1000 divided by 5 as 250, right? Now what will happen if I increase like this? What will happen if instead of that I'm going for R equal to 5, but now I'm increasing 1.5, whether I am on safer side or I'm on unsafe side? What will happen? Finally, this, how much is this value? Yes, anybody? Just answer me that 5 divided by 1.5 and
3.33. 3.33.
That means now under importance conditions, see, for residential building I'm going for 20, and for important buildings I'm going A divided by 3.3 means 33%. Yes. So I'm increasing the base shear. What will happen if I go for this equal to 1.5 and this equal to 3? So it will be 50%. Yes. See, 3 divided by 1.5, it will be 2. That means A by 2, that means 50%. Yes or no?
Yes, sir.
So see, reducing R will increase my base shear, and increasing I will also increase my base shear, but there will be some golden mean where this value R by I must be having a balanced value. and that I think code wants that. I don't know. Code wants that. So that is how I have analyzed, but I don't know whether my analysis is correct or not, because I tried to confirm it with uh, 4 5 prominent experts in this area, but they say नहीं नहीं बोल सकते क्या है, रहने दो, वो कोड ने दिया है ना तुम्हें आर बाय आई, रखो वो वैसे ही. But code wants this some value. That is what I feel. आप इस पर जरा थोड़ा ज्यादा सोचेंगे अच्छा रहेगा. अब आप बोलेंगे सर इतना कहाँ सोचेंगे, जो है वो समझा तो वही बहुत है. यस, यस सर, नो.
सर एक्स्ट्रा भी सोचेंगे सर, आपने बताया तो करेंगे.
नहीं नहीं, सी आई एम गिविंग यू द गाइडलाइंस फॉर फर्दर स्टडीज, and that's why I'm not going to say that मैंने ऐसा किया वैसा नहीं बाबा. मैं आई एम ऑल्सो अ स्टूडेंट ऑफ अर्थक्वेक इंजीनियरिंग. मैं एक्सपर्ट नहीं हूँ, but I'm trying to develop myself more and more with proper methodology, with proper analysis and justification. अगर जस्टिफिकेशन गलत है तो मानना पड़ेगा कि सर मैंने गलती की. अगर किसी ने आपको बताया कि नहीं नहीं ये तुम्हारा पार्ट गलत है बिकॉज कोड वांट्स दिस, मगर उसके लिए भी आपको सोचना पड़ेगा. गलत सोचने के लिए भी सोचना पड़ेगा. You can read this and you can go with this. Now you can go through this and you will see that little bit difference. Okay, this we have discussed already. So percentage increase in net bearing pressure. No, don't worry about this. You may leave it as it is. Okay, so these are the seismic zone factors. You know that second, third, fourth, and fifth. So this might get changed after few years, because then we'll be having additional information, and based on that, it might get changed. So don't consider anything in this as a stationary, because the things are if you start the entire process of this 1893, you will see that the first thing is that this is sixth edition. That means earlier there are five editions, and you will see that in every edition there are some advantages. कुछ पिछला निकाल दिया है, कुछ ऐड किया है, कुछ मॉडिफाई किया है, कुछ टोटली outside kiya hai. So that is how the science goes on working. So you can see right now, you can see dynamic analysis agar karna hai. Effect of design earthquake loads applied on structure can be considered in two ways: equivalent static method, dynamic method. Then dynamic method, you are having response spectrum method, then modal time history method, and a time history method. सो ये टू एडवांस्ड है. आप यहाँ पर भी काम किया तो आई थिंक इट इज मोर देन इनफ, बट दोज हु आर interested, they can go ahead with this modal time history. Okay, then in the standard equivalent static method, response spectrum method, time history method are used. Okay, so this is a map again. This map may get changed later on. Yes, clear.
यस सर.
तो अगर कुछ एडिशनल पढ़ना पड़ेगा, मैं सारा कुछ तो नहीं ले सकता हूँ. पर्टिकुलरली ये टाइप ऑफ सॉइल्स, अगर आप में से जो फाउंडेशन इंजीनियरिंग में बहुत अच्छे थे, उनके लिए यू कैन गो थ्रू दिस MI, MH, CI, CH. So these are the different types of soft soil. So that has been characterized in soil dynamics or soil mechanics, let's say foundation engineering. So you can go through this and you can check the compressibility, etc., all that, so that you will understand why the code has defined type A, B, and C. Right now, he is going for this, but we are not designing anything in type D. So you can see unstable, collapsible, liquefiable soils. Now, liquefaction is again one advanced concept, or say advanced soil engineering concept. And I will say that if you you come across such a sort of soils, better don't design the building in that area, because that liquefaction is a very very complex process, and many times you may have understood that soil, what is called as burning, that is sand burning or bubbling. So the soil gets converted in liquid,
Yes.
and that is called unstable, collapsible, and liquefiable soils. So that soil uh, absolutely loses all its shear strength, and it becomes just like a liquid. And then you can see what will happen when your building is resting. Just try to compare that condition with a ship standing in sea. So you will feel that is a liquefiable condition. Okay. Yes.
Yes, son.
Yeah, that's why you can see that. And if you have any queries, you can ask me. But I think today you people might have get bored a lot. वो करना पड़ेगा, कभी ना कभी करना पड़ेगा. Yes, but all of you are still there. That means at least you have that enough daring to stay with whatever I was just saying. Yes, Avinash. Hello.
यस सर.
सही हो रहा है कि बोर हो रहा है?
सच बोलूं सर?
हाँ
सच बोलूं?
हाँ, बोल ना बाबा.
मैं बीटेक में भी इतना थ्योरी नहीं पढ़ता था सर. थ्योरी में पढ़ा ही नहीं आता कभी.
नहीं नहीं नहीं, वही तो प्रॉब्लम है. क्या है, वाई वी आर नॉट परफॉर्मिंग टू आवर्स मैक्सिमम एफिशिएंसी. सी, हम लोग शिकार हो जाते हैं, क्योंकि हमें लगता है यार नहीं यार, मैं थोड़ी आगे जाके क्या कर सकता हूँ. मान लो अगर मोदी अगर कहते हैं यार मैं तो चाय वाला था, मैं थोड़ी पीएम बन सकता था. ये
किसने देखा सर कि प्रधानमंत्री चाय वाले? तो मैंने तो नहीं देखा.
नहीं नहीं, अभी देखो यार, पीएम जब खुद बोलते हैं कि मैं चाय वाला था, तो वो एक्सेप्ट करना पड़ेगा ना.
सर मैं पॉलिटिक्स पर, जो बंदा पॉलिटिक्स कर रहा है मैं उस पर कभी विश्वास नहीं करता हूँ.
नहीं, वो तो उसके टीचर ने ही बताया. वो वहां पे कई लोगों ने वो तो गवाही दी है, उसमें कोई वो नहीं है.
नहीं नहीं, वो जाने दो, पॉलिटिकल बातें जाने दो. मेरा कहने का मतलब क्या है कि यू कैनॉट प्रेडिक्ट द फ्यूचर.
यस.
एंड पहले हारने के पहले हार मत जाना, ये
नहीं
मेरा कहना है.
वो
सोल्जर सोल्जर नेवर क्विट्स टिल हिज डेथ, ऐसा.
यस सर,
Yeah.
डेफिनेटली.
तो अगर इस ढंग से हम अपना एटीट्यूड क्रिएट करेंगे ना, तो आपको लगेगा कि कितना भी कॉम्प्लिकेटेड इनिशियली लगने दो, बाद में आपको वो सारा आसान लगने लगेगा. ये मेरा एक्सपीरियंस मैं आप लोगों के साथ शेयर इसलिए कर रहा हूं कि मैं चाहता हूं आप लोग भी इससे, मैंने जो किया उससे डबल टिबल कर लो. तब मैं कहूंगा कि आप लोगों ने मुझे प्रॉपर फीस दी. नॉट इन टर्म्स ऑफ मनी, आप परफॉर्मेंस में जब दिखाओगे ना, तब मुझे सचमुच ऐसा लगेगा, यस, मुझे मेरी फीस मिल गई.
कोशिश रहेगा सर.
या नहीं नहीं, डेफिनेटली वो सी, आगे चल के ही पता चलेगा. अभी तो थोड़ी पता चलेगा. अभी तो वी आर फाइटिंग. अभी तो द मैच इज नॉट ओवर. मेरा कहना इतना ही है कि वन शुड नॉट डिफाइन हिमसेल्फ दैट नहीं नहीं यार मुझे नहीं आएगा। क्यों नहीं आएगा बाबा, सारी चीजें है ना सामने, इंटरनेट है, लोग हैं, आप आगे चल के कोशिश तो करें खींचने की। ओके, सो यस समीर।
सर मेरी तो कोशिश
सेशन में
कोशिश
कुछ
रहती
नया
है सर।
नहीं नहीं, वो कंटिन्यू रखो,
यस सर।
ये मेरा कहना है, मेक
यस
इट
सर।
कंटिन्यू, ये हमेशा के लिए आदत डालो।
नहीं सर,
Not only
मेरी
about the-
पढ़ने की आदत है सर मेरी तो।
नहीं नहीं, वो मैं आप दोनों के बारे में मैं आश्वस्त हूँ, नहीं तो क्या है आप लोग नहीं तो मेरे साथ इतने दिन टिकते नहीं। मैं सुलेखा मैडम के साथ भी आश्वस्त हूँ, मुझे वो थोड़ा थोड़ा डाउट आता है, क्यों पता नहीं, ये केतन मुझसे बात क्यों नहीं करता, यही मुझे समझ में नहीं आता। बात करनी पड़ेगी यार, नहीं आता है छोड़ो, वो बाद में आएगा। यस केतन,
यस सर।
बात करना पड़ेगा, और उसके
Yes, sir.
लिए मैं कहूंगा ये अविनाश और समीर दोनों को तुम अपना आइडॉल मान लो।
नहीं
तो
सर,
अविनाश,
इतने बड़े नहीं है कि आइडल मान हम लोग।
नहीं नहीं यार, सवाल वो नहीं है। सी, जो अच्छी चीज है ना वो हमेशा कॉपी करनी चाहिए, किसी के पास भी हो, ये मेरा कहना है। बड़ा और छोटा बात छोड़ो, और हम कौन है किसी को बड़ा और किसी को छोटा बोलने वाले, बराबर ना।
यस सर।
वो तो बाद में हिस्ट्री सी आगे चल के पता चलेगा, 100 साल के बाद कोई बड़ा था या छोटा था, अभी नहीं पता चलता ना।
यस सर।
Yeah. Okay, then with this, then if you want me to go with the ductile detailing, then in next session we'll go with 13920. Otherwise, we'll straight away jump into that ETAP model. वो आप मुझे बताइए नेक्स्ट टाइम when before I start the process. अगर आप बोले कि सर नहीं ये सेशन जरा 1392 के लिए 920 के लिए रखे, जैसे ये 1893 के लिए था, तो विल गो विद दैट, बट उससे एक सेशन आपका बढ़ेगा, आपका टाइम थोड़ा एक्सटेंड होगा, ये मैं पहले बोलता हूँ। क्योंकि लोग बोलते हैं नहीं नहीं वो टिपिकल टाइम में ही वो खत्म करो, मैं बोलता हूँ नहीं है, बात पूरी होनी चाहिए, उसके लिए कितना टाइम लगा उससे मुझे फर्क नहीं पड़ता, बट इट डिपेंड्स ऑन यू। अगर आप लोग चाहते हैं आई शुड go through that 13920 and codal provisions and how it has been related with 1893, so we'll go with that. Otherwise we'll straight away enter into our ETAP model, then we'll analyze it and we'll see the results and we'll try to find some conclusions. Yes.
यस सर।
ले सकते हैं सर वो 13920।
हाँ, आप लोग अभी अभी क्या करो, आज आप अपने वो ग्रुप पर एक दूसरे से बात करो।
यस सर, वो डिस्कस कर लेंगे सर।
हाँ, और मुझे बताओ, अगर आप हाँ गए तो भी मुझे कोई प्रॉब्लम नहीं, आई विल गो थ्रू, और अगर आप ना गए तो भी मुझे कोई प्रॉब्लम नहीं, आई हैव लॉट ऑफ थिंग्स दैट आई हैव टू कंप्लीट, तो डोंट वरी अबाउट मी। थिंक आप लोगों को चाहिए तो और नहीं चाहिए तो ये आप लोग डिसाइड करो, और मुझे नेक्स्ट सेशन शुरू करने के पहले बताइए। ओके
ओके सर।
ओके
ओके सर,
थैंक यू।
थैंक यू सर।
गुड
नाइट सर।
नाइट, गुड नाइट,
Thank you, sir. Good night, sir.
गुड नाइट, गुड नाइट।